This second video looks at logarithmic functions, and a log function is the inverse of an exponential function. Okay, so the last video, looked at exponential functions. So y is equal to, or fx equal to a to the x, that's our exponential function. Now we write that an inverse function, we learned about that in outcome 1, is f to the minus 1 of x, and our log function would be log to the base a of x, and that is read log to the base, we say the name, which is a of x. And hopefully you will notice, so I'll just write that's our logarithmic function. Okay, hopefully you will notice that the base of the exponential function is also the base of the logarithmic function. So notice the base of both functions are the same. So that allows us to be able to convert from one function to the other, just like we can do with any inverse function. You can convert from the original function to its inverse and back again. So before we look at how we can convert from one function to the other, we're just going to have a quick look at the graphs of these two functions, and so that we can see the inverse relationship. Right, so here is the graph of y is equal to 10 to the x, the exponential function. That's this one here. And then we also have the graph of its inverse, which is y is equal to log to the base 10 of x. And that's this function there with the second arrow. You can see that the bases are the same in both functions. So we have base 10 in the exponential, and we also have base 10 in the log. The graphs are a reflection across the dotted line, which is y is equal to x. So they're a mirror image of each other. But if we were going to place the mirror on the graph, the mirror would go on that diagonal line, y is equal to x, and the graphs have been reflected over. If we were to fold that piece of paper over, the graphs would be sitting directly on top of each other. In terms of the points, we will come back to the graphs, but on the exponential function, you can see that we have the point 0, 1. And on the log graph, we can see that we have the point 1, 0. So that is 0, 1. And then we have 1, 0 here. And hopefully you can tell that the x and the y values of those 2 points have basically swapped. So that is the result of the reflection. The x and values swap position. The x become the y's and the y's become the x's. Now we're going to look at how we can convert between exponential and logarithmic functions by algebra. So converting between exponential and logarithmic form. Okay, what we basically do is transpose the equations. So that's rearrange the equations. And we use the following relationship. So we've got y is equal to a to the x. And this means implies, but actually means implies in both directions, that log to the base a of y is equal to x. So we can go in both directions. That's what this arrow in the centre tells us. Again, our bases are both a, and what I would like to point out with our log is that the base is always a bit lower down. So it's not on the same line as the log and the y part. The base is written lower down, subscript. Now let me do a few examples of converting in both directions. Example 1, transpose y is equal to 5 to the x to log form, and log is just the shortened way of writing logarithmic. Okay, so we've got y is equal to 5 to the x. So if we're going to convert this to log form, basically the base of this part here, which is 5, is going to become the base of the log. So we write log to the base 5 of y, and then we're just left with the x. So the base of the exponential function becomes the base of the log. Okay, and so really this 5 is moving from this side to this side over here. Right, a second example. Transpose 16 equal to 4 squared to log form. Okay, so obviously 4 squared is 16, so this statement is correct, and we are going to convert it into a statement with a log instead. So we've got 16 equal to 4 squared. So our base is 4, so that's going to move to here. So we're going to have log to the base 4 of 16 equal to 2. If you were to place this part here into a calculator, you can do that, although it's slightly more complicated. You would need to use this button on your calculator. If you have that button on your calculator, they don't all have that. You would need to use this button here and then enter 4 for the base and 16 for the power, and you would end up with the answer 2. Most calculators traditionally only had an ln, which is the natural log. They had an ln button, and they had a log to the base 10 button. Often the 10 is actually not on the button, but that represents log to the base 10. Nowadays, newer calculators do have this button as well, although we probably won't have much need for it at this level. Okay, next example. Right, example 3. Transpose log to the base 2 of y equal to x to exponential form. So this time we're going in reverse. So just to show you that you can go in both directions. So we've got log to the base 2 of y equal to x. So 2 is our base, so that will become the base of our exponential function. Basically we just lose the log part. So y is equal to sorry, it's not e. I've just said that the base is 2. Let me rub that out. Y is equal to 2 to the x. And that's us in exponential form. And one more example of converting between logs and exponential. Example 4. Evaluate log to the base 16 of 4. Okay, so we're looking to solve this because we've got the word evaluate. So the first thing I would suggest we do is we make the log to the base 16 of 4 equal to something. It needs to be equal to something to evaluate it. So we will make it equal to x. Okay, now that we've got it equal to x, we can convert to exponential form. And the reason we can do that is this will be able to get a number that we'll be able to solve, hopefully in our head, without needing to use the calculator. So when we convert, we get 4 is equal to 16 to the power x. So what we're now asking ourselves is, what do we have to do to 16 to get 4? And hopefully you're realising that that would be the square root. To get 4 from 16, we need to take the square root. So basically we would have 4 is equal to 16 to the power a half. Why, if you're asking yourself why is it a power a half, remember that the square root of x is equal to x to the power a half. That's one of your indices rules. So if we just finish this off on the next slide, 4 is equal to 16 to the power a half. If we convert that back to logarithmic form, we now have our answer for x. We now know what x is at the start. So converting back, we have log to the base 16 of 4 is equal to a half. So the answer to the evaluation of log to the base 16 of 4 is a half. Right, now we're going to have a look at the graphs of logs. So the graphs of y is equal to log to the base e of x, which is also known as y is equal to ln x, the natural log, and y is equal to log to the base 10 of x. So as I mentioned earlier, these are the two main log functions, although in theory you can have any base for a log. But these are the two standard ones, and these are the ones that we can use on our calculator quite easily. So log, or y is equal to ln x, is the inverse of y is equal to e to the x, using the exponential function, and y is equal to log to the base 10 of x is the inverse function of y is equal to 10 to the x. So again, the bases are the same. You might be saying, well, there's no base in this one, but the ln represents log to the base e. So it's just an alternative way to use it, and that's what you would see on the calculator, the ln. Right, if we were wanting to use the calculator, I'll just again mention these buttons so that we've got it all together. On the calculator, if we wanted to evaluate log to the base 10 of x, we would press the log button. Okay, so it would just be the log button, and if it was, for example, log to the base 10 of 5, or it might be written as just log 5, then in your calculator you'd press the log button, and then you would press the number 5 followed by obviously the equals, and you would get the answer 0.699. That's a rounded answer there. If we wanted to evaluate log to the base e of x, we would use the ln button, and an example of that maybe would be log to the base e of 10, or again you could have ln 10. On your calculator you'd write ln followed by 10, and you'd get 2.303. So we would use this if we were trying to plot the graphs of these functions. We would pick x values, use the log or the ln button depending on the graph we were drawing, followed by the different x values to get values and plot them on a graph. And I will show you the graph of both log to the base 10 of x and log to the base e of x. Okay, so this will be log to the base 10 of x. Okay, so I had already drawn this shape when we looked at the inverse, the exponential and the log functions together. We pointed out this point here that we had 1, 0, and then I've drawn another point in there as well. So I'll write the key points and any things to notice on the next slide, but before I do, just again look at the graph and see that the graph does not cross the y-axis this time. So the graph is coming down here, going negative, negative y, but never quite getting to x equal to 0. So x equal to 0, which would be the y-axis right here, is never touched by the graph. So y just keeps getting very, very negative to negative infinity, but x equal to 0 does not exist. So that would be an asymptote if we were thinking back to outcome 1. Right, so the key points. We had 1, 0, and we'll just explain why, since log to the base 10 of 1 is equal to 0. And you could check that on your calculator using log 1. And our other point was 10, 1. Again, that's when we have log to the base 10 of 10, we have 1. So any log 1 will be 0. So it doesn't matter the base here. So it wouldn't matter this number here. If you're followed by a 1, you're going to have 0 as your answer. And any log that has the same base as the power will give you 1. And that's always going to be true as well. Now these are the values, the same numbers that you had in the exponential functions, however the x and the y values have changed. So if I just in blue, I will write the coordinates that would have been the exponential function. Sorry, that should be a 10. This would have been the exponential function, so that would be the points on y is equal to 10 to the x. So you can see that the x and y coordinates have just swapped places, and that's a result of them being a reflection across that y-x line. Okay, now the graph of y is equal to log to the base e of x. We're going to have that same shape again. We're still going to have that point 1, 0. The only one that's going to be different is this other point here because our base is different this time. So it's E1. That's y is equal to ln x, or y is equal to log to the base E x. So I'll just add in the key points on this one. So our key points, we have our 1, 0, and we have our E1. And for both graphs, I'll write this on the next slide, for both graphs, there are no negative x values. So x is always greater than 0. Right, just like we did with the exponential functions, we're now going to be given questions where we're given graphs and we have to identify the equations of the functions that are drawing those graphs. Identifying log graphs or log equations from graphs. Example 1. The graph is in the form y is equal to a log to the base 10 of x passes through 10, 3, find A, and write the equation. Okay, so we will do that over the page, but we've been given the equation and we've been given a point, so we're going to do what we did in the last video and sub in the x and y values. Right, so we'll sub in 3 here. Right, so now we have this part here, log to the base 10 of 10, and I did mention a couple of slides back that any log where the power and the base are the same, we equal 1. So log to the base 10 of 10 is equal to 1. So we have 3 is equal to a times 1, so a is equal to 3. That means that our formula or an equation is 3 log to the base 10 of x. Right, example 2. We have been given our graph and we've been given our form of our equation and a point that passes through and asked to find a and the equation again. Now before we actually go and solve it, let's just have a look at the graph. It looks different from the previous graph and the two graphs of log to the base 10 and log to the base e. So we can see that this one appears to have been reflected across the x-axis. And again, from our transformations that we learned about in outcome 1, we should hopefully realise that that means a is going to be negative. So we have y is equal to a log to the base 10 of x and the point 0.110. So there's x, there's y. Let's sub in. So we have 10 is equal to a log to the base 10 of 0.1. Now that we can do on the calculator, so you would just have the log button on the calculator followed by 0.1, and we find that that is minus 1. It's equal to minus 1. So we have 10 is equal to a times minus 1, so a must be equal to negative 10. So finally our equation is y is equal to minus 10 log to the base 10 of x. And that concludes the video on logarithmic functions.